1.2 functions and basics of functions and their graphs. Basically, for it to be a function, or really to be a relation, it's just any set of ordered pairs. One thing that you're probably accustomed to is thinking, hey, it has to always be numbers. That's not always the case. In some cases, you can still have a domain and a range that don't involve values. That it can be, like in this case, like the example here is highest paid TV celebrities and their earnings in millions of dollars. So you have Oprah Winfrey, Simon Cowell. I'm not sure if that's supposed to be Tim McGraw or what. I don't know what. Phil McGraw. Oh, I did not know that was Dr. Phil's last name. I'm sorry. Just know him as Dr. Phil. There you go. I guess I am. I don't know where Steve Harvey is, why he's not on here, but, I mean, survey says he should be on there. Ellen DeGeneres and then Ryan Seacrest. So you have their values. So usually whenever you deal with any sort of relation, usually like the category or the time is usually going to be your domain. Not necessarily always the case, but that's pretty normal. And then if you do have a numerical value or like your output, it's going to most likely be a numerical value there. It's really hard to have any sort of relation and not have something have a numerical value. So usually that's your range or that's your Y. You know, whenever you do have a domain and range of the relation, so of this case, you know, you have 0, 10, 20, 30, 40 as far as being your domain. And then your range values are always, again, your second value. So like the 9.1, the 6.7, 10.7, so on and so forth. For it to be a function, remember, domain is the first set of numbers. Second set is the range. It has to, the domain has to correspond with exactly one range value. You can't have multiple domains. Okay, or multiple x values is what you're accustomed to in dealing with the domain. You can have multiple range values, but you can't have multiple domain values. So like on 3 and 4, everything's fine here. Really the big, as far as the two, I guess, issues you would see are right here. Okay. As long as you have the same amount or more domain values, you should be in good shape. Okay, it shouldn't send up any red flags. So, like in this case, my domain would just be the list of my x values. So 1, 2, 3, and 4. Range values then would just be 6, 8, and 9. Okay. Everything's fine. There are two x values that spit out the same y value. That's okay. It's when you have, like on 4, when you have two x values here that spit out the same y value. Okay. That's whenever you're going to have an issue. So, like if I would list my domain and my range, my domain in this case would be 6, 8, and 9, whereas my range would just be the 1 through 4, so 1, 2, 3, and 4. The red flag should get thrown up whenever you have more range values for domain values. Okay? That's should be your sign or, like I said, a red flag for there's some sort of issue here that something's not right. Okay? You can never have the same x value map onto a different y value. Okay? We did, like in Algebra 2, you did mapping, you did where you would have graphed these. Basically, if you would have graphed them, then you would have two values that are the same. You could even plug it in for like slope, stuff like that, where it's going to be undefined, because if you have matching x values, then you better have matching y values with those 2 points. If you don't, then it's not going to be a function. Basically, functions is equations. Not every equation with both x and y will be a function. Everything over here on the side wall that has the posters, okay, those are all functions. Okay, you know why? It says functions on there. So that's your first tip or your first hint that it's a function, is because it says line function, linear function, logarithmic function, exponential function. Since it says function, it's probably a function. I know, it's amazing, isn't it, Logan? Whew. So in some cases, you can always check to see if you have values that are going to repeat. Remember, if you have the same x value that you input, you better get the same y value. Okay? Easiest way to do it is solve the equation for y, okay, because you're used to graphing it as y equals and then everything else. So like on 5, where I have 2x plus y equal to 6, all I'm going to do is just subtract 2x from both sides and have y equals negative 2x plus 6. Well, what kind of function is this? Just a straight line, right? It's a linear function, okay? It looks very similar to y equals mx plus b, right? Hey, it's just a line. Okay, my slope intercept is, or my y-intercept is at 6, my slope is at negative 2, and I would just graph it from there. Whereas on 6, the problem lies whenever I move the x over to the other side, not so much whenever it's necessarily going to be a negative. So whenever I have y squared equals negative x squared plus 1, that's not really the issue. Okay, even whenever I take the square root of both sides, having a negative underneath the radical isn't so much of the problem. Now, it doesn't help, but if I have negative x squared plus 1, okay, there are a few values that, there really are a lot of values that if I plug into this aren't going to work because it's going to be imaginary. Okay, really anything over 1 is going to be a problem, right? Because it's not negative x squared, it's negative and then x squared. So whatever value I plug in for x, I've got to square it first and then I've got to turn it into a negative. Okay? So really there's only a small group of numbers that's going to work. Those numbers are basically between 0 and 1. Okay? 1 works because it goes to 0. But other than that, there's really not a whole lot that's going to work here. Okay? If I would plug anything in, okay, whenever I take the square root of any value, what's going to happen? What kind of answers do I have? Plus or minus. Okay? So no matter what value I plug in, 1/2, 5, whatever, okay, it's still going to have a plus and a minus. I'm still going to get 2 answers for one value that I plug in. Okay? That can't happen. You are used to function notation, basically just like f of x, g of x, h of x. Whenever you have to evaluate anything, all you're going to do is just take whatever it is inside. I'm really just going to take the whole parenthesis. And instead of it being an x squared, it's going to be a negative 5 squared. Okay? So whenever I do this, if I have, I'm just going to take the whole thing. Okay? I have some students that they just want to just deal with the negative 5. Well, that's fine. Okay? But you might as well put the parenthesis around it, because then, like whenever I have x squared, I know that I'm going to have negative 5 squared minus 2 times negative 5 plus 7. Okay, whenever I have to actually evaluate it. Okay, because if I don't include that parenthesis, it's going to change my answer with that negative 5 squared. Because negative 5 times negative 5 is 25, plus 10, plus 7. Add everything up, and I get 42. Even if you have x plus 4 or negative x, okay, it's still going to get plugged in. So wherever you have an x, instead of it being an x, it's going to be an x plus 4. So if it's x squared, I'm really going to change this to x plus 4 squared minus 2 times x plus 4 plus 7. Then I would do all of my computations. X squared plus 8x plus 16 minus 2x minus 8 plus 7. Combine like terms. X squared minus 6x, bless you, plus 15. Okay, so even if it's a variable inside the portion, the input value, okay, I'm still going to I'm going to put the whole thing in there. Okay, even if it's a variable, that's all right. Okay, if it's a numerical answer or a constant, even better. It makes it work. What? Yes. It would be plus 6x. Remember, vertical line test is just if I draw any sort of vertical line, if I hit more than 1 point, it will not be a function. If I only hit 1 point with my vertical lines, then everything's going to be just fine. So if, like on A, if I would just start drawing vertical lines, if I hit more than one spot, okay, if I hit more than one spot, then it's not a function. The first one's a function. The problem with the second one, boom, right there. Okay, or here, or here. I hit more than one spot, then I have issues. Okay. Same way with C. C's okay as far as being a function. D obviously is not. Whenever we deal with domain and range, remember your domain is your x values. Okay, you can either write it using set builder notation or inequalities, or you can write it in terms of interval notation. Okay, your domain are your set of x values, your range is your set of y values. So your domain, remember, if it is a closed circle, then it's going to include that value. If it is an open circle, then it will not include that value. Okay, remember, closed circle is going to be a bracket or a less than but not equal to maybe, or greater than and not equal to. And then if it's a closed circle, it's going to be, or excuse me, that's the bracket. If it's open circle, then it's going to be a parenthesis and it won't be included. Okay, your x values go from wherever it takes you from one to the other. If it goes on and it has that arrow, it just goes to infinity. Right? And remember, infinity, whenever we're dealing with interval notation, is just going to be a parenthesis because you can never land on infinity. So like if we look at example, like if we look at B. So what's my domain? here. What are my x values? What do they go from? Okay, I prefer writing in an interval notation just because I think it's a lot easier. So where does my x value start and where does it end? Starts at -2 and it ends at 1, right? Now, is -2 included? No. Is 1 included? 1's included because it has the closed circle. What about my range? Now, I will tell you, range is 1. It seems like if students are going to make a mistake, it's usually going to be with the range because they always read it from the top down. Read it from the bottom up. So what's my lowest y value? -1. Is -1 included? Yes. Where's my highest y value? +2. Is 2 included? No. Okay. Now, if you look at C, what's my actual domain on C? Where does the domain, where do your x values go to? -3 to 0. Is 3 included, or -3 included? -3 is included. Is 0 included? No. Okay. Why is it okay for my domain to go from -3 to 0 even though I have those open circles? What does it do? It just kind of jumps up to the next one, right? It stair steps up. Okay, this is called a stair step function, okay, or a piecewise function is what we'll call it, or what we'll talk about it on Monday. Now, what is my range though? What are my y values? -3, -1, and -2, right? -3, -2, and -1. Okay, they are constant values because it is just a horizontal line. Okay, there's not a range. Your range, or there's not an interval. It's just your range is or are those three values. It's -3, it's -2, and it's -1. Okay, your domain here actually has that interval from the -3 to the 0. But your range, on the other hand, are just the values of -3, -2, -1. Okay, because they are constant values.